subscribe our channel and press the bell icon.
Hi guys, welcome to Ontogenesys Automation Unfolding Technologies Quick Review and Quick Preparation Program. Guys, I am really very happy that my videos are you people are getting benefit out of my videos, and you people are sharing your views in WhatsApp with me and asking me more and more. And at the same time, I am really very sorry because of the lack of time, so I am not able to give you everything whatever you are requesting, and even it is not possible, it is not becoming possible that I can reply each and everybody you too. So my request is that you people should ask your questions to my Facebook or your YouTube comments, okay, so that and I will really try my level best to give you people the best solutions. Okay, so many mechanical candidates have been requesting that I should make some videos for them also. So today I am going to discuss about some mechanical topics, that is your thermodynamics, then your pressure, temperature, and I will discuss your cycles, thermodynamic cycles, Otto cycles, diesel cycle, Rankine cycle, etc. I will discuss here the pressure measuring devices, YouTube manometer, and temperature, absolute temperature, okay, boiler, turbine, etc. I will discuss. So watch the video till the end, and hope it will give you more benefit in your exam preparation. Okay guys, so let's start in a quick manner. So thermodynamics is what? It involves heat and work. Thermo means temperature or heat, you can say. So thermodynamic system that involves work, heat transfer and conversion is the thermodynamic system. What is open system? Open system, you know, mass energy transfer plus work transfer, mass transfer, energy transfer, work transfer. Closed system, only energy transfer and work transfer, no mass transfer. Closed system. Isolated system, nothing is transferred, not practical. Next is pure substance. Pure substance means unvarying molecular structure during thermodynamic process. Those molecules those substances who do not change their molecular structure during the process is called pure substance. Likewise, your water, they exist in three phases: solid, liquid and gaseous. Everybody knows these properties. Thermodynamic properties are, yes, extensive properties and intensive properties. See, many a time we get confused, extensive and intensive. Okay, so extensive properties depend on the extent of the material, and intensive properties are independent of the extent of the material. Extensive properties like total volume, total mass. Intensive properties like temperature, specific volume, etc. So remember, the cyclic process, initial and final state are same and identical. So in cyclic process, after process, the initial and final parameters are same. So quasi-static process, remember what is quasi-static process or quasi-equilibrium process? Each state may be considered as equilibrium. Deviation is infinitesimal. Means very minimum deviation occurs at instantaneous second, and we can consider each and every state as equilibrium. Now what is equilibrium? Thermodynamic equilibrium means mechanical equilibrium plus thermal equilibrium plus chemical equilibrium. Okay, only mechanical equilibrium means pressure equilibrium, is not it? Mechanical equilibrium means it is balanced, mechanically balanced. So pressure equilibrium. Thermal equilibrium means temperature balance, temperature equilibrium, or thermal equilibrium means temperature constant. Okay, and chemical equilibrium, chemically balanced. So if pressure balance, temperature balance and chemical balance, then only we can say it is in thermodynamic equilibrium. Process is in thermodynamic. Next is NTP and STP, normal temperature and pressure, standard temperature and pressure. Normal 0 degree 760 mm of Hg and standard is 15 degree and 760 mm of Hg. Guys, kindly verify this. I am a bit confused in this, which one is normal and which one is standard. Okay, so kindly do verify this one. Normal is 0 degree 760 mm and standard is 15 degree 760 mm. Anyways, next one is our thermodynamic process. Thermodynamic process, remembered what are the process? Likewise, isothermal process, isobaric, isochoric, isodiabatic, etc. No, so isothermal means the process where temperature is constant. See, temperature constant means you have to give continuously, you have to give supply of heat to that system to maintain that temperature constant. Okay, so energy must be supplied continuously. So isothermal system means temperature constant, isobaric means pressure constant, isochoric volume constant, adiabatic nothing is constant, and isentropic means entropy constant. Entropy constant. Remember isentropic means reversible adiabatic process. Okay, isentropic means reversible adiabatic process. So I hope you people know these things. Isentropic means reversible adiabatic process. Now what is entropy? Entropy is nothing but your degree of disorderness. And what is enthalpy? Enthalpy is the total energy, internal heat energy. Okay. So now first manner come to your laws of thermodynamics. You know, everybody know these things. Zeroth law, remembered? What was zeroth law? When two systems are in thermal equilibrium with another system, then all of them are in thermal equilibrium with one another, isn't it? When two systems are each in thermal equilibrium with a third system, then the two systems are also in thermal equilibrium. Okay, so this gives us the temperature definition, that there is temperature something heat. Okay, I am coming back. And next one is your first law. First law is also called law of conservation of energy. Remember this one, law of conservation of energy. First law, what was the first law? The heat and mechanical work are mutually convertible, is not it? Heat and mechanical work are mutually convertible. Or you can say that energy can neither be created nor destroyed, though it can be transferred from one form to other. That is why it is called law of conservation of energy or first law of thermodynamics. Zeroth law, this one, first law is law of conservation of energy. Now what was the limitation of that first law of conservation of first law of thermodynamics? The limitation is that it is not giving us any hints regarding how much percentage of heat can be converted into work or how much percentage of work can be converted into heat. Thus, the second law of thermodynamics came, and there are two laws basically in our second law of thermodynamics. One is your Kelvin-Planck, yes, Kelvin-Planck statement, and another one is your Clausius statement. Okay, so Kelvin-Planck statement and Clausius statements, both the two statements comes under the second law of thermodynamics, and it is called your entropy law. Entropy law. Now remember this name, entropy law is second law. Law of conservation of energy means first law. Now what was your Kelvin-Planck statement? What was that? Kelvin-Planck states that it is impossible to construct an engine working in a cyclic process whose sole purpose is to convert heat energy from a single thermal reservoir into an equivalent amount of work. Means it is impossible to construct an engine that can take heat from a single source and convert it to equivalent work without rejecting any heat or losing anything. So it is not possible. Nothing is 100% efficient, is not it? So this is also called law of degradation of energy. Law of degradation, remember this, law of degradation of energy. The Kelvin-Planck statement is also called law of degradation of energy. Okay, remember. And where eta maximum is equal to your Q1 minus Q2 by Q1, and I will not go in details because it is a quick review, quick preparation program, so I will go in a first manner. So next one is a Clausius statement. What was Clausius statement? It is impossible for a self-acting machine working in a cyclic process to transfer heat from a body at a lower temperature to a body at a higher temperature without the aid of an external agency. Means if we do not give additional supply or additional work, it is not possible to transfer heat from cold body to hot body. That means it is the based on this refrigeration has been produced. So Clausius statement states that it is impossible for a self-acting machine working in a cyclic process to transfer heat from a body at a lower temperature to higher temperature without aid of any external agency. And Kelvin-Planck states that no machine can take energy from one single source and convert it into whole work. Okay, so next one is your third law. Third law, what was third law? Law of unattainability. Law of unattainability of absolute zero. Third law states that law of unattainability or absolute zero, third law states that entropy of an ideal crystal at 0 degree Kelvin or at 0 Kelvin is 0. Means entropy of an ideal crystal becomes 0 at the absolute temperature, absolute zero temperature, is not it? Okay guys, so these were these things you know already. I just have given you a quick review. Now what was your Boyle's law? Boyle's law was PV is equal to constant, pressure and volume constant at constant temperature when delta T is equal to 0, and Charles' law is volume is proportional to temperature at constant pressure, is not it? And what was our ideal gas equation? PV is equal to nRT. You people remember, this is our ideal gas constant. Kindly do watch my first video, that is your units and dimensions, where I have mentioned this ideal gas constant and all. These are very important for you people. Next one comes the thermodynamic cycles. Very, very important. Thermodynamic cycles, is not it? So what are thermodynamic cycles? Carnot cycle, then your Otto cycle, Brayton cycle, is not it? So what are the Carnot cycle? It is an ideal cycle. Modified Rankine cycle. Modified Rankine cycle, based on modified Rankine cycle, steam power plant uses modified Rankine cycle. So wherever steam is involved, it is your Rankine cycle. Otto cycle, diesel cycle or dual cycle. Otto cycle, diesel cycle or dual cycle. It is IC engine or your diesel power plant. IC engine or diesel power plant uses Otto cycle, diesel cycle or dual cycle. Brayton cycle, gas turbine, Brayton cycle. Remember these cycles. Okay. Now nuclear power plant. Einstein equation, fission or fusion is used in nuclear power plant, is not it? Next one is your vapor cycle. Vapor power cycles are Carnot cycle, Rankine cycle, regenerative cycle, reheat cycle, binary vapor cycles. These are called your vapor power cycles. Gas power cycles, Otto cycle, dual combustion cycle and Brayton cycle. Gas power plant cycles, Otto cycle, diesel cycle, dual combustion cycle and Brayton cycles are called gas power plant cycles. See, these I will explain these cycles in my later videos. Okay, just remember the names and where they are used right now for your SSC, JE or APDCL exam. So Carnot cycle, it is an ideal cycle, not practical. Modified Rankine cycle, steam power plant. Otto cycle or diesel cycle or dual cycle, IC engines or diesel power plant. Brayton cycle, gas turbine, and Einstein equation is used for your nuclear power plant, is not it? And vapor power cycles are Carnot cycle, Rankine cycle, regenerative cycle, reheat cycle, binary vapor cycle. Gas power cycles are Otto cycle, diesel cycle, dual combustion cycle, Brayton cycles. Okay guys, so hope you people are getting me, and you people are able to recall all the chapters or all the topics, isn't it? So now I come to our next topic, that is your pressure. स्पाइरल टाइप का बर्डन ट्यूब होगा. दिस इज द बर्डन ट्यूब. यहां पे देखो ये फिक्स्ड है, हम पढ़ते आए हैं कि फिक्स्ड एंड. सो ये हो गया तुम्हारा प्रेशर गोज.